My name is Isaiah Rubin, and today I'm going to teach you about compound interest. So the problem we have here is the need for a large capacity water supply system is forecasted to occur 4 years from now. At that time, the system required is estimated to cost $40,000. If an account earns 12% per year compounded annually, how much is needed to be placed in the account at the end of each year? So for this problem, we can't approach it as a general compounding problem because as opposed to a single deposit being made in the beginning, which compounds over the 4 years, we have individual deposits being made at the end of each year, which will still, of course, compound. So to begin, we have our general equation. A equals P times 1 plus R over N raised to the NT, where in this case our A is our final value of 40,000, our P is our initial value which we are solving for, our R is going to be our 12% rate, our N is the number of compounding periods, which will be 1 since we're compounding annually, and our T is the number of years over which we're compounding. So from this point, we have to think of how each individual deposit will compound. So for our first deposit at the end of the very first year, we'll have our initial value, P, plus times 1 plus our 12% compounding annually, raised to the third. Now it's raised to the third because we're depositing it at the end of the first year, so it'll compound over the full second year, the full third year, and the full fourth year. Similarly, we'll have for our second year the same initial deposit P, the same rate, the same annual compounding, but this one will be squared because of course we're depositing it at the end of the second year, so it has the full third year and the full fourth year to compound. Continue this for the third year, where we have same rate raised to the first because it's compounding once over the full fourth year, and for our final deposit it won't compound at all because we're depositing it at the end of the very last year. So from here, we'll set this equal to our A value of 40,000. So 40,000 will be equal to P times 0.12 cubed plus P times 1.12 squared plus P times 1.12 plus P. Now from here, we'll just solve it algebraically. So our 40,000 is going to be equal to P times 1.12 cubed plus 1.12 squared plus 1.12 plus 1. So our final answer for P, our initial deposit at the end of each year, will be equal to 40,000 divided by 1.12 cubed plus 1.12 squared plus 1.12 plus 1. If you enter that all into your calculator, you get our final answer of P equals $8,370 to be deposited at the end of each year.